You had to find a number that multiplied to be 169. Now, if you guys remembered on the board, I don't know, it was before the last test. And I had the square root of 1, square root of 4, square root of 9. Let's go through this real quick. What's the square root of 1? What's the square root of 4? 2. Because it's 2 squared. What's the square root of 9? 3. Because it's 3 squared. What's the next square root? 16, which leads to 4. 5 would be the answer to the square root of 25. Those perfect squares, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 6 squared is 7 squared is 8 squared is 9 squared is 10 squared is we're getting close. 11 squared is 121. 12 squared is 13. 13 squared is 169. Now that's hard though, because if you don't have it memorized, you probably would need to get your calculator out and be like, divide by 3. Nope. Divide by 4. Nope. Divide by. It wouldn't work until you got to 13 because 169. Where are my markers? Where did I put it? Oh, here it is. 169 is not divisible by anything else. Can't be factored into anything else except for 13 and 13. My screen frozen. Just doesn't like it. Can't be factored into anything else besides 13 and 13. So if you don't have that memorized, that would be a little rough. Now wait a minute, hold on. How do we get x alone? We know that x is supposed to have 2 different answers. One is a positive and one is a negative. What do I do to both sides? What do I put in the problem to get rid of the square? Yeah, a radical. Because this whole section is called solving with radicals or square roots. Not just any radical, but a square root. But yeah. So if I put a radical on both sides, I think yesterday I was making them all yellow, but I have my red pen out, and it's hard to get yellow in this program. What does a radical do? Cancels out a squared. Now there is, do you remember that really snazzy, what most algebra teachers think is too hard for you to learn, that's technically true? The squared goes away, but there's not just an x left. Do you remember what else is left? Absolute values. And the absolute values say there are 2 answers that could come out. A negative and a positive. So that positive and that negative, and who was the guy that 169 is the square root of? Got it. So, what are my final answers? Good. And the other way of writing it is that snazzy plus or minus. Who doesn't like a shortcut? As long as it's right. But plus or minus, positive or negative 13. Andrew, is that good? Yeah. Would be our final answer. Now, can I rock your minds a little bit? You ready?
Yes.
Okay. There was an old-fashioned way before we learned our radicals. Don't worry, that's calculus. Before we learned our radicals, there would have been an old-fashioned way of solving this. I can get some blank space. Back before the semester broke, before Christmas, I actually, and even last test, I would have told you to get this in standard form first. And standard form says everything has to be on one side with the other side equaling, do you remember? 0. Wouldn't we have, let me get it read out real quick. Wouldn't we have needed to subtract 169 from both sides? That's what we would have done last test. We would have needed to get everything to one side. We would have gotten the equal 0. Max, make sure you're tuned in. We would have gotten 0 on this side. What would have been over here? Can we combine those? Are they like terms or no? No. Okay, good. So x squared minus 169. Weren't those standard form problems the ones where you needed to factor? And isn't this the special one where we have a negative 169 on top and a 0 on bottom? Oh, x plus 13. And the 0 on bottom would have told us we need to find the perfect square and make the difference of squares. Guys, the 13 and the negative 13, remember opposite signs. The 13 and the negative 13 can show up a couple different ways. We could have had to have done the standard form and then the factoring and then the pulling out the opposite signs. But check it. If we can figure out how to get a square by itself such that a square root can be put in, isn't this a little bit faster? But you're right, Andrew. 169 was a little bit rough. Now, coming back to homework, we did cover number 8. 169 was a little rough, but was there anything else on 3 through 14 you guys got stuck on? Jerry? Okay, go fast. Go fast. And make sure you're tuned in. more with the notebook than you would with the map. And then, let's tweak that. And then, anything else on homework questions? Okay, how did this section get a little bit harder than the first section? What was different in here? Yeah, you had to do some stuff, right? You had to get, what was the point? Who were you getting by itself? And you were getting the x squared by itself, so you could bring in what? How do we get rid of the squared once we get it by itself? We can bring in the radical, and then we can go ahead and solve and simplify, right? But where do we see us going in tonight's homework? You guys ready? I'm actually going to show you where you're going right now. Where are you supposed to start tonight? Okay, you're starting in the same section a little bit later where you have to do some steps, yeah? But then, what's the next section showing us? Ooh, there are parentheses. That's new. Can you look at your worksheet, flip it over, and let's see what's going on, 9.3b? Do you see parentheses? Nice. All right, let's get into notes. In order for us to be ready for homework tonight, we need to figure out what's going on with those parentheses. So, what do you guys see in the warm-up? I want you guys to do the best you can, just with us having gone over homework questions. There are two problems. They're not even numbered, I don't think, are they? Two problems. I just want you to think, with what we just saw, how do you think we could solve for x? Got it. All right, 9.3b. Just, what do you think? What do you think? When would there be a square root? When do you think there would be a square root? All right, I'll let it slide. That's helpful. Make sure you're paying attention today, though. What do you think? Which one do you think is more like last night's homework? The one on the left or the right? Yeah, so try the one on the right first. Here's the worksheet from yesterday. You want the back side. That's where these problems are. You lost them. Yeah. But first, let me just write that problem. Try this one first. The question in your brain as you go the rest of it. How do you do that? Is anybody getting weird numbers on that second one? Yeah. It's all right. All right. It's a weird one. Doesn't mean you don't know the steps. It just means you get to it 2/5 and you're like, oh. Yeah. It's all right. That's all right. Get to the 2/5 and then be like, now what? Put a question mark. We'll come to it in a second. But any idea? 12. I don't want to go telling you answers. That's no fun. We're supposed to be like discovering and playing with what we know. Math, the kind of cool thing. Someone came in this morning and was like, how can kids do all that math? Look on the sideboard. Those are the formulas my honors pre-cal kids have to have memorized today. There's actually 3 more sections with tons more like physics and vector diagrams and forces and crazy stuff that they got to make a note card on. That's the stuff they have to have memorized. The other ones they get to have a note card on. And they're like, how do they do all that math? Well, I know it looks like a lot for you guys because we don't usually memorize lots of formulas. But I also know in other classes you've memorized stuff before, like in science or maybe in history. In studying, you have to memorize dates or vocab words. You have to memorize vocab words, right? How to spell them, how to use them in a sentence. With math, what's kind of cool, it's kind of like English and it's kind of like foreign languages. If you go to Spanish today, or if you go to French today, or even if you go to English today, Do you have to walk in and just be like, oh, stink, I have to memorize every single word she says? Do you have to memorize every single day, every single word they're saying?
Yeah.
Or is the point to become skilled at the words, to be able to use them in whatever way you want or whatever way you need? Right? You're not necessarily like reading an essay and being like, oh, I have to memorize that essay word for word and be able to regurgitate it someday. It's like, no. Think through what the author's saying and how they're saying it and how they're making their point well or how they're making it badly, and then learn from that to be able to argue or to be able to persuade or to be able to write or to be able to analyze on your own. Math is kind of similar. Like these formulas, yeah, they're good, and there's like this foundational truth to math that's even more solid than a lot of other areas. So you can think kind of like a foreign language. If you learn words, if you learn their proper tenses, if you learn how to use them well and use them right, you can string them together in your own way to be able to create something. Math is kind of similar in that you're supposed to kind of be seeing patterns and learning those patterns and these general truths and then be able to use them in kind of crazy ways. What am I saying? I'm curious what you were able to do now that you know that a square root cancels out a squared when it's put in the right place. Meaning, I asked you to start on this one because it was like, if you guys look at this, don't you see that x squared is kind of like stuff? And don't you know from all your previous training in math, you're kind of trying to get the x alone? Okay. It's there. Are there times in life where there's all kinds of messiness going on, and you kind of have to dig down to see, that's the main objective, that's what I need to do. I need to kind of ignore all this, but I need to ignore it in a way that's proper and legal and doesn't mess me or my job or my family or anybody else up. All that to say, what's the proper way in this equation to get towards that x squared? What'd you guys do first? Plus 2. Why'd you do that? Hopefully because you know it's legal and it's a way to properly undo the minus 2 that's in my way. Right? Okay. So then we get the 5x squared equals 2. True? Sure. Like if you're going up for a shot and there's someone in your way, what's the proper way? Do you plow through them and then draw like an offensive shot? Well, I don't know if their feet are planted, but do you just like shove them out of the way into the wall? Or yeah, there's a legal way to get to your goal, right? And there's an illegal way. Same with math. I need to get to the x. The legal way is to add the 2. Okay. I still need to get to the x. What's a legal way to keep going? Divide by 5. True? And I get x squared is equal to. Now, some of you, when you see yucky stuff in math, you just like tune out. And you're like, I don't like it, so I'm going to stop. That could have happened right here because you're like, I don't like the 2/5. And I get that. But stuff can happen in life you're not going to like. Are you just going to throw in the towel and be like, well, let's try something easier? I hope not. You're not going to accomplish much. The 2/5 is there, and it's no big deal, as long as we just keep going, and to some extent, try to glean from the wisdom of others that are like, this is how you keep going. I'm just curious if you were brave enough to put in a square root, even though you didn't like the 2/5. Were you brave enough? Did you know you were allowed to? Because I have to somehow, did you put in the square root?
Yeah.
I have to somehow get rid of the squared. I have to somehow get to x. I know you don't like the 2/5, but that's the only way to proceed forward, the only legal way to go. To undo the x squared, I got to put in the square root. And now, hold on. The square root takes away the squared. That's good. I have finally gotten to that little x guy who's so elusive and he's always like getting into trouble and I have to go bail him out. Okay, I got him. Now, Kayla, if you want to be amazing, what's technically around here? When I square root is squared.
Oh, the absolute.
Yeah. There's technically absolute values, which means there's a plus or minus. That's a positive number. I know you don't like it, but we can technically do it in our calculators. And most of your calculators that you guys have been using, borrowing from me, which isn't ideal. You should have like your nice, neat one that you can always use and you're super familiar with. Anyway, that's a whole other issue. But coming back. When we throw in a square root of 2/5, I just want you guys to see, even though it's a fraction, like we can still know it's a positive number, and because it's a positive number, there are 2 answers. I'm just proving to you it's a positive. It's not a negative, it's not 0. Okay. We know it's a positive, we know x has 2 different answers, but here's the problem. How do we write those 2 different answers? Okay, so if I was to write right now, absolute value of x is equal to the square root of 2 over 5, I am not wrong. If I was to say absolute value means there's one positive and one negative, I'm still not wrong. The problem is, this is not the proper way of writing it. This is not the proper way of writing it. Who cares about being proper? Let's just box it and be done. Okay, so that's your job one day when you show up not in uniform and they're like, well, that's a strike, there's another strike, now you're fired. You have to be in, you guys see Chick-fil-A, they're all wearing like the ham pants and like the red shirt. Like you gotta do what you gotta do when you have a job, right? If you want to keep the job. So, we have a job to do, and our job is to make this in its simplest form. In section 9.1, the quiz we took on Friday, I had up on the board, you guys had your like steps 1 and 2 and 3. What's not proper about this answer? It's right, but it's just not simplified. What's wrong? It still has the radical. Well, actually, I can't always get rid of the radical. We've had some really nice ones in homework that we could get rid of the radical. But what's underneath the radical? In section 9.1, we learned sometimes the radical's stuck. But where is the radical not allowed to be? The denominator. Yeah, it's not allowed to be in the denominator. So does anybody remember? Now I'm going to give you a hint. We are allowed to, if you want, we can actually even hold off on this whole plus or minus thing until we have the right answer. We can actually hold off on, if you have it ready, and just put it on my desk. You can do that plus minus thing later. Okay, we'll get back to the answer once we have the good form of it. For right now, I can actually remember, I can split up tops and bottoms. We saw that in section 9.1. That's why we had to talk about radicals, because we need it now. This isn't a pretty answer. You guys are right. There's no nice whole number for what this is. It's a nasty fraction. It's one of those quadratics that cross through the x-axis at weird places that we have to eyeball. And we're trying to get more precise. I don't mind the radical up top, but who do I mind? The radical in the bottom. And there's a snazzy word called rationalize. And there's a snazzy thing I always do whenever I see a radical in the bottom to get rid of it. It starts with multiply. My question is, what do I multiply by?
5.
Yeah, but not just 5. I need radical 5. Right? Now, up top, am I allowed to put the 2 and 5 together? Is it 2 times 5 is 10? Yeah. Ooh, I know. Some people think no, but since they both have radicals, I'm allowed to put them together. You think they're both in the house, so go ahead and multiply. The top will be radical 10. My question is, what will the bottom be? Radical 25, or radical 5 squared, which reduces to be 5. Now, this is section 9.1, where we rationalized. It was in improper form, so I'm not going to my plus or minus yet. I'm actually still just kind of holding on to that plus or minus in my absolute value, being like, okay, I get it. There are 2 answers. I just don't want to have to do this twice. I'm going to do it once, and then I'm going to make it proper. Now, some of you are looking at this and being like, the 5 and the 10, I can make it a 1 and a 2, but why is that illegal? Why can't we reduce? What's stopping us from reducing right now? The radical. Subtract the 10. I can't get it out. So at this point, I'm done. There's nothing else I can do. The radical is outside of the denominator, meaning I've done my job. I've written it in its proper form. Whoops. And some of you are like, wait a minute, you told us there was a shortcut. Like, I'm not going to write all that. Why not just write it as x equals what? What's the shortcut way of writing? Plus minus. So if you want, you can always just do that instead. You don't necessarily have to write 2 different numbers. Okay, was this example way different than yesterday? The answer was, but was the process way different? No. Where did it get weird? Right here, where you guys were like, I don't know what to do. But technically, I just did what we did yesterday and last night in homework that almost no one had questions on, because we still put a radical on both sides. We still have a plus minus answer. We just had to make it look proper by going back to 9.1 and reminding ourselves of what that looks like. I ran out of whatever word I was going to say. Kayla, what's up?
How did you get 5 when you were multiplying?
Oh, this is the proper way of rationalizing, is to always look at who's in the denominator, and we multiply top and bottom by that.
but like when you're multiplying across.
Oh, sorry, I didn't show the word for that. Let me get a new clean page real fast just because I'm running out of room right there. We could make this root 10. That part made sense? Over root 25. Another way for some people to see it that's a little bit easier is to remember that 25 is just 5 squared. And either way, whether you have this memorized as 5 times 5 or whether you realize what you can always do with the perfect square, then we were able to go ahead and say, oh yeah, that's just 5. Is that cool? As you get more and more familiar with it, your brain will be able to make that jump. I just made that jump because we had seen it in 9 and 1, but you're right, it's been a while since we've seen it. Okay. I know the answer. Took some work to make it proper. Yeah? But the math didn't really change. We were adding the 2, dividing the 5, square rooting both sides. We needed a plus or minus answer. We just had to make it look good. Or look proper, I should say. Does anybody have any ideas? Thinking about keeping it legal, thinking about trying to get X alone. Does anybody have any ideas about what they think would be a legal way to start this problem? Max? Okay, that actually is one way. One way, he's thinking like, hey, PEMDAS, I can do the squared. He's thinking I could go ahead and he's not wrong. And in the olden days, meaning like last semester, we would have foiled. We would have been like, this isn't standard form. I need one side to be equal to 0. But are we actually keeping one side equal to 0 anymore now that we have square roots? Okay, so the old days get equal to 0. So we would have had to FOIL and get it all like a trinomial, move the 36, a trinomial, and then factor. But Max, actually, it's to our benefit that it's written like this, because I have a squared equal to a d. It's just a little bit harder. It's not an x squared equals d. I'm going to call it, and I know it's crazy, I'm going to call it a u squared equal to d. What I mean is it's not x alone, but it is still something or someone squared. It's actually a good thing. It's still a squared equal to a number. Foiling is one way, but can anybody think of anything else that's a little more creative that still uses what we know in math to legally start this problem? Andrew?
You can, with the exponent, you could do the 1 times 1. What do you think?
I think you're thinking foiling too, though. I think you're trying to actually do the square, right? Yeah. You're actually trying to do the square. I'm saying there's another way besides squaring first. Yeah, Kim.
Wouldn't you like do what he's saying, like 1 times 1 and then subtract the 1 both sides, so it'd be 35 on the other side?
Yeah.
I would love subtracting the 1. The problem is right now he is stuck. And so actually the only way to get him unstuck and out of those parentheses would be to do what Max is saying. And that's going to take a lot of work. Like the 1 would have to be times the 1, but remember we also need our first and our outer, and it's going to get real messy real fast. And that might be a way of going. I'm just curious, since we're in a section that says solve with square roots, and we have a squared equal to a number, does anyone else have another idea, even though you're not wrong? Trey.
36.
What about 36?
Square root it.
Square root it. Now, Trey's looking at this saying like it's a nice number. He has a square root. So be careful, because we might see numbers that aren't nice. Like those ones over there, like 2/5. The reason that we're square rooting isn't because of the 36, so I'm glad you saw that. The reason we're square rooting is because of the, we could actually avoid the square and not have to FOIL. And not have to FOIL, not have to multiply by saying, wait a minute, we know how to get rid of squares. We can actually avoid FOILing by putting a square root on both sides. So the same way down here, I had an x squared, and I'm like, I don't want you to be squared, I need you to be by yourself. And we put in a square root. If we ever have, if I were you guys in a colored pen, I would show these parentheses. If we ever have, if I could put my hand on it and say block, if we ever have a block squared, I can get rid of that squared and not have to FOIL because of a square root. I can get rid of that squared and not have to FOIL because of a square root. If I ever have a block squared, so an x squared with a number, or a block squared with a number, I can throw in a square root because a square root and a squared cancel. A square root and a squared cancel. So what's left? 2x plus 1. Now careful, careful, careful. I don't want Kayla to answer it. She's answered it twice today. I need someone else to pick up on this. When a square root is squared, what's technically around it? Set the, what are these called again? Absolute values. Yeah, absolute values. Careful, careful.
6.
But over here, I can say, yeah, because 36 is 6 times 6, right? And the square root of 6 squared is just 6. Are we okay making that jump?
Yes.
From 9, 1. Okay. Now, hold on. Those absolute values are slowing us down, and they have to slow us down because, guys, I had a squared equal to a positive number. How many answers do I need to get? 2. And theoretically, a positive and a negative, but hold on. Positives and negatives come from the absolute values. So actually, I'm not going to come down here and do positive, negative of my final answers. I'm going to come right here and say, wait a minute, 2x plus 1, the absolute value slows me down and says positive or negative. It can be a positive 6, or 2x plus 1 can be a negative 6. Those absolute values were important because they slow you down and they say, whoa, 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 whoa. There's 2 ways for this to become a 6. Either what's inside is a positive, staying a positive, or the inside is the negative, flipping to be positive. So here's where it gets a little weird when you have a block squared. You need to slow down just a little bit and say, okay, you could either be a plus or a minus 6. Now guys, I can't just write it like that anymore because it's not my final answer. It's a step in the process. But once I get here, now the equation is super easy to solve. Because all I have to do is get x alone in each one and get 2 different answers. Max, did I answer your question?
Yeah.
Cool. So now we just have to solve. And there's no crazy squares needing a square root anymore. Real quick, just kind of poke everybody in your group on their shoulder. Real quick, everybody, or at least like something close between their shoulder, their head, something gentle. We have lots of people falling asleep. Poke, 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 poke. Just poke someone in your group. Poke, poke, poke. Okay, there we go. I think everyone has their eyes open again. Here we go. So, help me out real fast. How do I get x alone? Subtract 1. Hands to yourselves, hands to yourselves. Thanks for the quick help. Okay, so 2x is equal to 5. And over here, 2x is equal to negative 7. Good, good, good. And to finish, divide by 2 on both of them. The nice thing is their steps are exactly the same because they're both coming from the same 2x plus 1 expression. Focus, Andrew and Edward. Thank you. So then I end up with x is equal to 2 different answers. But do you guys see how the numbers are different? But one is a positive, one is a negative. Now, Max, be careful. Actually, because this whole plus or minus, positive, negative happens way up here, there are times I have 2 positive or 2 negative. But I needed to have that positive, negative happen wherever the absolute values are, and then just kind of let the math go where it goes.
Okay.
Is that cool?
So whenever you put like a radical, you have to put absolute value? Okay.
Because that slows you down to say, oh, whoa, 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 I need a positive and I need a negative. Otherwise, our brains go too fast. Once we get the hang of it and we say, 6, but we might accidentally only solve for 1 answer when we needed 2. Okay. Or we might solve for 1 and say plus minus, and we're totally wrong. Does that kind of make sense? Yeah. Kiddos, this is how it gets harder. If you guys just a second ago were looking at where the homework goes, do you see a lot of block squares, right?
Yeah.
Where or how are we going to start every single, well, almost every single problem? We're going to do a radical, right? Ooh, I like radical 0. It's just 0. I like that one. Hey, radical 4 is not bad. Radical 9 is not bad. Radical 81 isn't bad. Do you think I should do a radical right away on these?
Oh, no.
Distributing is a little bit illegal, even though I like the idea.
Okay.
Because this squared PEMDAS says I would have had to have FOILed before multiplying, exponent before multiplying. So actually, I wouldn't say distribute because you would have to FOIL, and we're trying to avoid that.
Okay.
But couldn't I divide both sides by 9?
Yeah.
Remember, we want the squared to be alone first. We want the squared to be alone first. And some of you are like, you just made that number so awful. It was fine a second ago. Now it's awful. Let's see if our worksheets have anything to help us out on that. Yeah? Oop, that's a random blank page. Oh,